Hello Professor, I am Sena Yazan. In this presentation we try to explain AC servo motors. What is servo? Firstly we have to learn servo. Servo performs angular linear position, speed and acceleration control in mechanisms without error. In short, it is a motion control mechanism. What is servo? Servo motor is part of a closed loop system. Current and voltage supplied to this system. Servo motor produces torque and speed with this current and voltage. It is also servo controller. This servo controller uses a feedback device. There are two types of servo motor, AC and DC servo motors. AC servo motors are types of brushless motor used in both low and high power applications. Also have simple structure and low inertia, generally nonlinear and highly magnetically. There is an encoder part, but encoder part will be explained in the following slides. There is servo motor structure, rotating shaft, stator iron core, permanent magnet, and stator winding and encoder. There is a table. There are a lot of differences between induction motor, DC servo motor, synchronous AC servo motor, and inductive or asynchronous AC servo motor. In this presentation, we mention more about asynchronous AC servo motor and synchronous AC servo motor more detailedly.
Mainly familiar, my topic is construction of AC servo motor. AC servo motors consist of four basic and two auxiliary components: stator, rotor, encoder, shaft, winding, and bearing. The picture, there's a video. Stator. The stator contains two windings with an electrical engine of 90 degrees between them. These are main or fixed winding and control winding. Rotor. The rotor is generally of two types: squirrel cage type and drag cup type. The squirrel cage type of rotor, small diameter, large length, baseless, constructed with aluminum conductors, diameter-length ratio is low. Torque slip characteristics of AC servo motors should not have a positive slip region because these motors has a high stability. The drag cup type rotor. It consists of a laminated aluminum core in which the drag cup is located. It is used in application with low power requirements because these two air gaps on either side of the core reduce inertia. Encoder. Overall, an encoder is a gauge or process that converts information from one format to another. The optical encoder always works the number of rotations and the position of the shaft. A servo mechanism is a motor sorted out with a criticism sensor and regulator to frame a shut circle control circuit. In the circuit, the sensor arranges the accompanying activities. Notice the mechanical movement of the actuator shaft, converts the mechanical input into an electrical impulse, and transmits a series of such impulses. Resolver. Resolvers are for position detection in alternating current servo motors. They are feedback elements that are used and produce analog signals. The resolver is an electromagnetic device. Thank you.
Working principle of an AC servo motor. Stator contains two windings, control winding and main winding. AC voltage supplied to the main winding, and starting voltage rotates shaft. Because of this shaft, there are two angular positions, control transformer and synchron generator angular position. These two angles are compared and error occurs. This error signal is at the same level as the voltage at the control transformer and transmitted to the servo amplifier, which generates the control voltage. After this voltage, the rotor reaches a speed again and starts to rotate. It keeps rotating until the error signal is zero. After all these situations, the AC servo motor reaches the desired position. All of these creates alternating flux. This alternating flux field rotates and velocity builds up. The relative speed causes an electromagnetic force induced in the rotor. This force is the same as the magnetic force in transformers. The current induced in the rotor will also produce an alternating flux field around itself. This rotor flux cannot keep up with the stator flux. If the rotor fails to catch the stator flux rate or is not synchronous, it is asynchronous type.
Hello, I am Mustafa. Today I will present types of Hsr motors. Hsr motors are classified into four types. Two-phase Hsr motor. Usually used in control systems, this motor is used in high-frequency relay systems. Frequencies can be 60 Hz or 400 Hz. In two-phase Hsr motors, the stator consists of two windings distributed at an electrical angle of 90 degrees from each other. The voltage of the control phase of these motors is provided by the servo amplifier. On the other hand, the control winding of two-phase servo motors is supplied with an additional voltage whose amplitude can be adjusted. Three-phase servo motors are used in applications requiring high power. Three-phase servo motors have nonlinear characteristics. Therefore, the control process is more complex than two-phase systems. This motor comprises of stator and rotor. It is stator of this motor have cylindrical frame and stator core. The rotor consists of a permanent magnet and shaft. It does not depend on AC induction type rotor. Induction type AC servo engine structure is like the general motor. In this motor, stator comprises of stator core, armature winding, and lead wire, while rotor comprises of shaft and the rotor core. In this page, advantages and disadvantages of AC servo motors. And this page, difference between AC servo motors and DC servo motors.
Hello, I'm Berkay Gaznevi. Now I will present to you general motor equations, basic horsepower calculations, and AC servo motor efficiency. In this slide, I will give you information about general motor equations. The first equation is about the synchronous speed, frequency, and pulse. The equation is N synchronous equals 120 times F divided by P. N synchronous is synchronous speed, Fe is frequency of the system. The second equation is about the motor slip. The equation is S equals N synchronous minus Nm divided by N synchronous times 100. N synchronous is speed of magnetic field and M is mechanical shaft speed. The third equation is about the torque power and speed. The equation is tau equals P divided by omega m. Tau is induced torque in Newton meter, P is power in kilowatt, omega m is speed in hour per minute. Fourth equation is about starting current calculator. The equation is IL equals S start divided by square root of 3 times Vt. S start is rated horsepower of the motor times code factor, Vt is rated voltage. Basic horsepower calculations. Horsepower HP equals voltage times amperage times EV percent times power factor times this constant value. Power factor is the ratio of true power kilowatt to apparent power kilovolt ampere. In the absence of power factor measurement tools, a rule of the thumb is to estimate power factor at 0.85. AC servo motor efficiency. Industry are finding that items should convey more noteworthy execution and dependability while utilizing less power. In this figure, you see different size of motors. Servo motor efficiency curve. Servo motors are intended to be more than 85% productive. A servo motor's performance curve provides information about speed, torque, voltage, and thermal conditions. This figure, you see performance curve of servo motor. How to read motor speed torque curves. The thermal line shows the region at which the motor is running at its most extreme plant state of 155 degrees. In this figure, you see performance curve and pushing the limit.
Hi, I am Olcay. AC servo motor losses, constant or fixed losses, iron or core losses. The core losses rely upon frequency of the supply voltage. The frequency of stator is constant supply frequency, which is always less than the stator frequency. The rotor core loss is very small as compared to stator core loss. Mechanical and brush friction losses. Mechanical losses occur at the bearing and brush friction loss occurs in a wound rotor induction motor. These losses are zero at start, and with increase in speed these losses increases. Variable losses, core or copper losses. The losses happen because of current following in stator and rotor windings. As the load changes, the current following is in rotor and stator windings also changes, and henceforth these losses also changes. Hysteresis losses. Hysteresis losses are related with the energy needed to go through a complete cycle of the BH curve. Eddy current losses. Eddy current losses are circles of electrical current induced within conductors by a changing magnetic field in the conductor as per Faraday's law of induction. Eddy currents make a magnetic field that resists the change of magnetic field that created it. These power parts, frequency, induction, thickness. Anomalous losses. Anomalous losses interrupted the AC heating of the copper wire and potential size impacts of the device. Anomalous losses are generally negligible. AC motor servo motor drive. I have searched how to make simulation of AC servo motor drive. We have to use PWM inverter. Anyway, they can be analog or digital form. This is more expensive than DC servo drivers. This is high performance. Give high performance in control position, speed, and torque of servo motors. We do position control with fuzzy. They appear as analog or digital devices with inductors that show the engine status. Servo drivers all have their own unique features. Vector control of brushes AC servo motors. A speed test based on vector control of AC servo motor will be checked. Now, brushless AC servo motor current vectors. This is our figure. So, these are equations. Three-phase state to D and Q coordinate system. These are equations, and this is the equations of the stator DQ and rotor DQ transformation. Since the rotor has permanent magnet, D coordinate current is assumed 0 and Q coordinate I is assumed as the reference current. Thank you for listening.
Hello everyone, my name is Fatih. In this section, I will try to give you information about position control using fuzzy logic control and observer-based control. Let's get started with fuzzy logic control. What is fuzzy logic control? How does a fuzzy logic controller works? A fuzzy logic control system is a control system based on a mathematical system that analyzes analog input values in terms of logical variables, take on continuous values between 0 and 1. We will use this system in our simulation to find the actual position of an AC servo motor. On the other hand, we have another control system, which is observer-based control. An observer-based control is a dynamic feedback controller with a two-stage structure. First, the controller generates an estimate of the state variable of the system to be controlled. Using the measured output and known input of the system, this estimate is generated by a state observer for the system. What we are doing here is fuzzy logic control and observer-based control. We will compare these two control systems to find better results in our simulations. As you can see here, our simulation to position control of an AC servo motor. You can see the calculations, you can see the functions here, observer-based control. There are deeply calculations are available on our reports, so I will not mention about equations here in these representations. Let's get a look at our output. There are three lines here. What is these lines? What it means? The red line is fuzzy logic control of an AC servo motor position control. The green line shows us the approximate position of an AC servo motor with observer-based control. And the blue one is the desired step response of our simulation. We will compare these two control systems each other. This table shows us the output of the performance data, which are rise time, percentage overshoot, settling time, and peak value. As you can see here, physiology control, percentage overshoot, and settling time is better than observer-based control. As you can see here, 11% and 6 seconds. The simulation result for tracking the desired step input position signal improves that the AC servo motor with physiology controller improves the settling time and the percentage overshoot, while the simulation result for tracking desired input position signal proves that the AC servo motor with physiology controller improves the settling time with 0.7 seconds and with 0% overshoot. As you can see here, there are lots of applications of AC servo motor. A couple of them you can see here. For example, robotics, conveyor belts, solar trackers. Thank you for listening.